Hello guys, welcome to my lecture series of digital electronics. So in our previous lecture we have discussed about four number system named as decimal number system, binary, octal and hexadecimal number system. We have also discussed about the available characters in all these four number systems and one rule or one formula according to which we can decide the combination of different characters to form any number. In today's lecture we are going to discuss about the streamline method, which is very fundamental and popular method to convert any number from decimal to binary and vice versa. So let us begin. Streamline method is used to represent any decimal number by its equivalent binary and vice versa. Calculations from this method is easy for smaller numbers. Now this method uses the block representation in which weightage of each block increases in the power of radix, moving from LSD to MSD. Now two new words that introduced in this slide is LSD and MSD. Now this LSD represents the least significant bit or digit. If it is binary number, then it will be LSB, so you will use bit over there, or in any other number system it will be digit. Okay, in general you can use D. And similarly MSD means most significant digit. So the meaning of LSD and MSD are very simple. LSD is the coefficient LSD is a coefficient of the smallest power of radix. And similarly MSB is the coefficient of the highest power of radix. Let me give you a very simple example. If I am having a number say 15,324, fine. So according to formula, this combination is governed with 10 raised to 0 multiplied by 4 plus 10 raised to 1 multiplied by 2 plus 10 raised to 2 multiplied by 3 plus 10 raised to 3 multiplied by 5 plus 10 raised to 4 multiplied by 1. Now here very interesting observation is that all the coefficient must be the character of that number system. Here 15,324 is a number of decimal number system. So 1, 5, 3, 2 and 4, all these are the characters of decimal. Okay, so if we talk about this number, then what is the coefficient of least power of radix? So least power of radix is 0, as you can see over here. So, and the coefficient of 10 raised to 0 is 4. So this 4 is called LSD, or least significant digit. And what is the coefficient of highest power of radix? So as you can see, 1 is the coefficient of 10 raised to 4, which is the highest power of radix. So here this one is nothing but MSD. Okay, so I hope you are clear with these two words, LSD and MSD. Any number is developed from its LSD to MSD. This is very important thing to understand. Fine. You might also have observed that any arithmetic operations are also performed from LSD to MSD. Okay, say for example, if I want to perform 327 plus 416, then this arithmetic summation will always start from LSD. No one can start this addition from MSD. Okay, so this is very common thing actually, but it is very serious when you come at the verge of rules. Okay, so I will repeat myself once again. Any number is formed from least significant digit to most significant digit, and any arithmetic operations also performed from least significant digit to most significant digit. Now, as we discussed that this streamline method is a block representation, so each block over here is given some weightage. So if the number system selected is binary, then we will have 2 raised to 0, 2 raised to 1, 2 raised to 2, so the increasing power of the radix. We might have some binary point, and to the right hand side of that binary point we will have the negative power of the radix, so 2 raised to minus 1, 2 raised to minus 2, 2 raised to minus 3, and so on as per our requirement. Now say for example, if I want to convert this number 178.75 from decimal to binary, then according to the streamline method, what will I do? I will first have the arrangement of blocks as per my requirement. See, in the integer part I want 178. Okay, and 2 raised to 8, if I go further left hand side, then I will have 2 raised to 8, which is 256. So I am very clear that I am not going to need this power of radix, okay, because my number is less than 256. Okay, so the highest power of radix that I am going to require to represent 178 is 2 raised to 7 only. Okay, so first thing is to decide where to stop. Okay, so it is very simple. Your number must be less than the power of that radix. Okay, then we'll have a point and the negative power of radix, that is 0. 2 raised to minus 1 is 0.5 and 2 raised to minus 2 is 0.25. Okay, so how can we do that? So 178, that means I must need to utilize this 128, so I will put 1. Now remember, the coefficients will only be the character of number system. Please remember this thing. Coefficients can only be the characters of that number system. Now I am willing to write 178.75 in binary number system. So binary number system is having radix equal to 2 and 2 characters 0 and 1. So all the coefficient of these blocks will either be 0 or be 1. Okay, nothing else can be taken. So to form 178 I have utilized 128. What is the remaining number? So 178 minus 128, so you will have 50 over here. Now if you want to make 50, that means you are not going to use this 64. Okay, so you will put 0 over here. 32 must be used, so you will put 1 over here. Now 50 minus 32, you will have 18. So again you will use 16 over here because it is smaller than 18, and 16 plus 2 is nothing but 18. So all the other parts will be 0. Then we'll put a binary point over here. Now we want to make 0.75. So 2 raised to minus 1 is 0.5, 2 raised to minus 2 is 0.25. If you add this 0.5 and 0.25, you will have 0.75. So you will put 1 over here, 1 over here. Okay, and this is the conversion of the number 178.75 from decimal to binary. Okay, so this number can be represented into binary as 101100.11 in binary. So whenever you are dealing with the same number system throughout, at that time it is optional to represent, but for this discussion, when the number is defined in different number system, so it is a good practice to always represent a radix as a suffix of that number, so that one can, because see 10110010.11 can be the number from decimal number system or octal or hexadecimal. Fine, it is not clear to your audience up till you do not represent the radix. So when I put 2 in the bracket, then you will understand, okay, this number is binary. Okay, so as we discussed in our previous lecture, any data in binary will have the highest length. So 178, it is having the length of 3 character in decimal, but 3 plus 3 plus 2 and 8 character length in binary. However, the value of both these number are same. Okay, so with the help of streamline method, we can convert any decimal number into binary. We can also do it in a reverse form. So let us take a couple of examples. Now suppose we are having a number 1992 in a decimal and we need to convert it into a binary number. Then the very first thing that is to be decided is what will be the highest power of radix. So as you can see, 1992 is less than 248. So we are not going to use this 11th power of radix. My representation will be covered into the 10 power of radix. Okay, so in order to form 1992, we will use 1024 because it is less than 1992. So if 1992 minus 1024 is performed, then you will have 869. So 968. Now to form the 968, you must utilize 512. So again, so if you are going to utilize that power of radix, then you must put 1, or if you are not going to utilize that number, then you put 0, because in binary only 2 characters are there, 1 and 0. Fine. So the next step will be 968 minus 512. So it will give you 6, 5, 4. So 456. So again, if you want to make 456, you need to use 256. So again, put 1 over here. 456 minus 256 will give you 200. If you want to make 200, you are going to use 128. So 200 minus 128, so it will be 27. Now to make 72, you will use 64. So 72 minus 64, 8. Now to make 8, you are not going to use 32, you are not going to use 16, but you will directly use this 8 and all the other coefficient will be 0. So 1992 in decimal can be represented by 11111001000 in binary. So both are equivalent to each other. Okay, now in the reverse conversion, if you want to convert any binary number into a decimal one, then also streamline method is very helpful. So first you write the binary number from LSB to MSB. So here in this example, I am having a binary number as 100111. 0101. So I will write this number from LSB to MSB 1 1 1 0 0 1. Okay, now the reverse conversion is very easy, because as you can see, this 1 is nothing but the coefficient of 2 raised to 9. So 2 raised to 9 is nothing but 512. So just list out the value of this power: 256, 128, 64, 32, 16, 8, 4, 2 and 1. This is nothing but the increasing power of the radix. Okay, so what will be the next step? Whenever the coefficient is 1, that will be those values will be added to each other. So 512 plus 64 plus 32 plus 16 plus 4 plus 1. So 1 plus 4 5, 21, 21 plus 32. Okay, let us do it over here. 512, then 6 plus 4 plus 2 6, 6 plus 3 9, and 16 plus 4 plus 1 is 21. So 6 plus 3, it is 9, it is 12. So it is 629 in decimal. Okay, so streamline method, actually this is a proven method, but it is very difficult for a larger number. Fine, because you need to do a lot of work for the conversion. Streamline can also be used. By the nature of this method, we can also use this to represent any number from any number system to decimal number system. Say for example, if I am having a number 7046 in an octal number system, so as you can see, 7, 0, 4 and 6, all 4 are the characters of octal. And if I want to represent the equivalent decimal number of 7046, then the fundamental logic will be same. I am going to use blocks and the increasing power of radix. So 8 raised to 0, 8 raised to 1, 2, 3, 4, 5, up to whatever extent I need to have to cover this 7046. Then now 8 raised to 0 is having the value 1, 8 raised to 1 is 8, 8 raised to 2 is 64, 8 raised to 3 is 512. Okay, so now putting the coefficient, so the coefficient of 8 raised to 0, or the 0 power of radix, is 6. 1 power of radix, the coefficient is 4. For the square of radix, the coefficient is 0, and for the cube of radix, the coefficient is 7. So as you can see, 7046, we are going to use the power of 3 of radix 8. Now we simply multiply this radix with the coefficient. So 512 with multiplied by 7, it will give you 3584. 64 multiplied by 0 will be 0. 8 into 4, 32, and 6 into 1, 6. And by simply adding all these values, you will have 3622 is the equivalent decimal number of 7046 octal number. Okay, so that is it. Streamline method is not that much popularly used for the conversion. Rather, we use the double method for the same. Double method will be explained in the next lecture. And for today's activity is you just try to find out the decimal equivalent number of a hexadecimal number 8A2. Okay, give it a try for yourself. Otherwise, refer to my next video lecture to know the answer. Thank you very much.